In this video, we're going to take what we've learned about intersections and unions of sets and apply it to a figure, in this case, a quadrilateral. We have our quadrilateral DCBA, and we're going to look at different intersections and different unions within that figure, and figure out what we get. So let's look at this. We have AB, the segment AB, intersected with the segment BC. So here's AB down here. And then here's BC right here. Okay, so what do these two have in common? They have this point B in common, right? So the intersection of AB and BC is point B. Okay, what about ray EC? So ray EC union with ray EA. Now we have EC union with EA. So the thing that we want to note here is that it's the rays. So when we say ray EC, I mean, it really is extending on past our figure. And when we say ray EA, it really is extending out here past the figure. So if I union those two rays, well, we get a line, right? So we can name that line any number of things. We could name it line AC. That's probably what I would choose, just because that seems most natural to me. But you could also name it line AE or line CE or EC or EA, right? As long as you've got a line that contains all of those, the union of those two sets, right, of EC and E. Okay, let's look here at AC, ray AC intersected with line BD. So AC, ray. Again, that goes past. And line BD. So line BD kind of starts out there and goes past. Okay, what's the intersection there? Meaning all the points that those two have in common. Well, it's just point E. Right? It's this point here in the middle. So, yeah, it's point E. Pretty straightforward, I think. Okay, segment AB intersected with segment DC. So here's AB. Here's DC. Do those intersect? No, they don't, right? Oh, yeah, no, they don't. They don't intersect at all. So remember, when we have two sets that never intersect, that's the null set. There's nothing there. Okay, what about ray AC? Ray AC and ray EC. Ray AC intersect with ray EC. Well, hopefully, again, you're picking up the pattern. These two, that's my shaded area is right here for both of them. So since they share that, the intersection between AC and EC is ray EC. And remember, think about subsets as well. If you wanted to say, this is kind of an aside, but you could also say that, if I can get it figured out, EC, ray EC is a subset of ray AC. I just want to get your brain thinking in that direction. Okay, two more examples. What about ray BA? So here's ray BA right here. And ray BC. The union of those two sets. So earlier we did the intersection of the segments. Now we're doing the union of the two rays. Well, remember, two rays make up an angle. So the union of BA and BC is actually the angle ABC. That's pretty cool. Okay, last but not least, the union. Okay, we've got a three-parter. The union EC and CB and BE. Well, if I were to take all three of those and union them together, I create a nice triangle. So the union of those is triangle. Well, you could call it ECB or BEC or CBE. And that triangle is the union of all three of those segments. Hopefully this was helpful, and just some more ways to think about the intersection, the union, and even a little bit of subset of sets.